Hello everyone and welcome to another video in Stat385. In this video we're going to go over objects and functions. Okay, so there's this famous quote from John Chambers, a very important person in R, who says that to understand computations in R, there's two slogans that are very helpful. And one is that everything that exists in R is an object and everything that happens is a function call. So that's it. That's the course, essentially. And you've already, worked with functions and objects, but of course we're going to have to go into them in more detail. And so let's pull up so we have our R Studio. I've already opened up the R project. You can see where I'm in right now in Stat385 on my desktop. Okay, so I'm going to create a new script and let's just demonstrate some objects, things you've already done. So a number, a string here, and a logical call. Okay, so if I hit command return, there they are. Okay, so these are just basic objects. One's a number, one's a string, one's a logical value. And you will see, of course, when you call the code, you can see it appear in the console. So I guess, one thing to note here is that the output that we see in the console is not, technically the object itself, but rather the result of our printing information about the object for you. Okay, so a very important concept is to take an object and assign it a name. Okay, so we can say take 42 and we can use an assignment operator. I'm going to just scroll down here, it's a separate thing. Okay, I'm going to take the object 42 and with the assignment operator, give it the name X. Okay, so now we have the object 42, which is stored in R's global environment, which you can see the objects that are stored, and it is given the name X. So now I can call X directly, and we can see that it prints out the value 42. Okay, so one thing to keep in mind is that R is case sensitive. So for instance, if I create another object 43 and give it, let's demonstrate this way. If I were to, so I just called lowercase x, if I call uppercase X, it's going to complain. It says error, object capital X not found. However, little x exists in the global environment. So now, if I want to use the object, or if I want to use the name capital X to give to a separate object, I can do so. And now you can see that we have a new value capital X, which points to the object the string stat385, which is in global memory. Okay. So just to avoid confusion, I'm just going to clear the global environment and start over. Okay. So R console still running, global environment cleared because I don't want this lecture to contain lowercase x and capital X. I think that we've demonstrated the point here. Okay. So a few things. There's two different ways of doing assignments in R. There's the equal sign, and then there's this arrow, which is two keystrokes in order to use. So it's been pretty standard convention in R to use this convention for assignments. However, a strong vocal minority is now switching to the equal sign, and it is a little bit faster. It's going to agree with the textbook more. So we're going to use this one. And really, the reason for this assignment taking off in the first place is more legacy. There's actually specialty keyboards that had this assignment operator in one keystroke, and now that's a relic of the past. I think that probably the only remaining legitimate reason for using this is just to differentiate creating objects in the global environment from arguments inside of a function call, which uses the equals convention. We'll get into this in this lecture where I'm getting a little bit ahead of ourselves here. But yeah, so anyways, we can use either as an assignment operator. I don't really care which one you use. It doesn't really matter to me, but I'm going to try to stay consistent with the textbook materials and trying to use less keystrokes when I'm working. So I'm making a shift over to this convention for assignments. Okay, great. All right, you can also, right now it's really, really simple. We're just demonstrating the idea that you can create objects and assign them names. But as tasks become more and more complex, you may want to give something an actual descriptive name. Now, perhaps that's a little bit too long. A long variable name describing the object. But you can see that we can create it, and then if we know what the name is, we can reference it. There we go. Okay. We don't need to linger at this point too. But of course, keeping in mind that if we're going to give very long descriptive names describing the object, that R is in fact case sensitive. So this becomes a bit more of an art for how you want to create or give your objects names and whatnot. It becomes useful in data frames and stuff like that. But again, you don't want to give your object a name that's too long that you're not going to remember, or just like mix up cases, because that's going to create a headache for yourself. But then again, something as simple as X is maybe you don't know what that actually means in the current project, especially if you work on multiple projects simultaneously or have done multiple projects in the past and you use the same variable names and these like sort of generic, not very information rich names, then you're bound to get confused. So again, more of an art than a science. Okay, so we saw that when we created when we created objects and assigned them names, they appear over in the global environment. We can always check out what is hanging out in the global environment by calling objects. So we can see a long variable name describing the object is there, and so is X. And over in the global environment, we see that they're referencing the same object 42. Okay, again, I don't want to keep having this thing around, so I'm gonna clear the global environment and keep my, okay, so now if I hit objects, nothing's there. And we'll just keep this running. Okay. All right, so keep in mind that you can keep in mind just the order in which you evaluate options. So for instance, if I were to have this string of operations, so what I'm doing is I have the object 1, which I'm assigning the name P, the object 2, which I'm assigning the name Q. Okay, so right now we can see P and Q over in the global environment. So now what I'm going to do is take P, which is a name referencing an object, and assign it the current value and assign the object which Q currently points to. Then when I do this, you can see, well, you already see what happens if you track the global environment, change the value, and now P is equal to 2. But if you were to switch up the steps slightly, okay, so you assign Q equals 2, P equals Q, and then P equals 1, then P is back to equaling 1. So, this is very useful, giving objects names, especially names that are descriptive, but you have to keep in mind that as you're working in R, that you can overwrite previous values. So that's why I'm being a little bit of a stickler to just clearing the global environment constantly and then kind of starting over with where I'm at, so that I'm staying oriented. But nonetheless, it is useful to be able to update and change values as well, which we'll see later when we use functions and arguments. Okay, so now there's this. So now we'll discuss one of the most primary and widely used objects in R, which is a vector. Okay, and one of the most basic ways to create a vector is using this C function, which is combine. Some people have said concatenate in the past. I like combine better. And so basically what we can do is use this C parentheses and then supply objects in it. Objects of the same type, which we'll cover type a little bit later. And so now, what is this thing? So it's combining 3, 2, and 1 into a vector. And let's see what it returns. So it just returns 3, 2, and 1. This little value 1 here is just indicating the, it's just orienting you on how many elements there are in a vector. So the first element is 3, second element is 2, third element is 1. It's not really that helpful when there's not that many objects, but if I were to do something like, I don't know how many I have to create. Oh, I needed more. Oops. Okay, so then you can see that eventually I ran out of space, and now the 32nd element is 7. And you can see that you can get a little idea what the length of this vector actually is. Of course, we could just... Okay, well, this is getting a little bit cumbersome. So why don't, instead of doing that, I have my big vector here, give it a name, or I take my object, which is a vector of all these numbers, and I assign it the name y, and then I can see what the length is. Okay, it's 34 elements. All right, great. Okay. Again, I don't like that. We're gonna clear the global environment. All right. So what I did is a keystroke, Command Shift, and then down arrow, highlight everything that I have, and then just run it. Okay. All right, so we can see how we can take numeric objects, number objects, and combine them together using the C function. We can also do the same with strings. Okay, so for instance, if I have a string, which is a character, another character string, another character string, I have 3 of them, I can combine them together to form a vector. This isn't the same thing as combining them together so that there's one single string with all of these terms. That would be something different, which is possible in R, but down the road. But we can see that we have a vector of strings. So if I were to give it a name, okay, then we can see what the output is. So the first element of this vector is the string, a string. The second element of the vector is the string, another string. And the third element is a string, one more string. Okay. We can do the same thing with logical elements as well. Okay. And these can also include not an element, which we'll cover a little bit later. Okay, great. So, all right, so we have basic objects, assigning names to objects so that they appear in our global memory, so that when we call X, we're really pulling out the value for the object 42. And then of course we can create, I am gonna overwrite it. Okay, so now I don't necessarily care about the number 42 anymore. I'm gonna have the vector X, you can see it changed in the global environment, the vector Y, the vector Z. So, okay, so now let's continue with this idea of creating numeric vectors. Okay, so I have odd numbers, 1 through 7, even numbers, 2 through 8, and this thing that we'll just call big, which is all of the whole numbers between 1 and 10. Okay, so I have 3 objects, 3 numeric vectors. I can use the combine function to combine these vectors together. So for instance, I could do C number, or object, which is 42, not in the global environment, object odd, which is the vector of odd numbers from 1 through 7, vector of even numbers from 2 through 8, and I can put 42 on it. And then the combine will just create a bigger vector consisting of numbers. So you can see when I called it, we have 42, 1, 3, 5, 7, 2, 4, 6, 8, 42. Okay. So this is just a simple foray into objects, mostly just vectors at this point. Okay. And of course you can, take this, make this as large as you like. Okay. So now those are objects, mostly numeric vectors. We have some other vectors that we covered, and we can kind of show how, we can create basic objects, gives objects names so that they appear in the global environment. That's slight shorthand for what's going on. We can create more complicated objects as vectors, as long as they can consist of the same type, which we'll get into type in a little bit more detail next week. And then we can, combine these vectors together. Okay. So now let's move into functions. Okay. And I'm going to create a new thing. Clear the global environment. Okay. Okay. So the simplest function that we can write, I always like to give myself a line. I don't know why. Okay, so f equals function with parentheses designating where you would put arguments or inputs, and then curly braces where you would have like the body of the function to take your inputs and do tasks and then return an output. Okay, so let's run it. This is not going to be very interesting. Okay, so run it, and we can see that our global environment now contains the function f. Okay, just go back to the previous tab here just to demonstrate a point. Say I take my object 42, which I assigned the name x to, and create it. So now we can see that our global environment panel in R differentiates between values and functions. So we have objects up here, in this case a numeric object. We could also add a character vector, and we have functions. Okay, cool. All right, so this thing right now isn't very useful. We can run it. We can call the function using f parenthesis and it just returns null, didn't do anything interesting. Alternatively, we could just reference f. So remember, f is this function that exists in our global environment. We can reference it directly, and we can get, what happens? We get function, it just displays the code that creates the function. Okay. All right, so let's do slightly more interesting function. Let's create one that calculates the perimeter of a rectangle. So here I'm actually giving the function a descriptive name. When we were doing objects earlier, the names weren't all that descriptive, but now you can see that this one has a slightly more descriptive name for the task that we're going to do. Okay, so previously this is where the arguments go. We didn't do anything for the first function, so let's do stuff now. Length, height, right? Perimeter is a function of length and height. Okay, so now I have argument specified. Let's do stuff in the body so that this function actually returns the desired thing, the perimeter. 2 times length plus 2 times height. Actually, I do like saying it 2 times, so I might as well. It won't matter. And, we don't necessarily need the parentheses, but I think that including them just makes things easier to read. And I think it's a good convention to adopt, even if it is slightly redundant. Okay. So now we have our function, we have our arguments. Let's try it out. Okay, so let's first save it. Now it says it. I don't need to copy it. I can start typing, and eventually you can see that a little menu came up, which allows me to fill it in, and I can hit tab, or I could hit tab. Okay, so now if I hit tab again, it'll pull up the argument, the first argument of the function. So let's try it out. And so comma to close out this argument. And now I can hit tab for the second argument. And here we go. So is the perimeter of a rectangle with length 3, height 4, that's equal 14, right? Yeah, so it looks like it's doing the right thing. And of course, change this and see what happens. Okay. So far, so good. Okay, so again, if we were to, just call the function directly, R is going to complain because we haven't actually set a default value for any of the arguments. So, if I were to specify length equals 3, this is going to complain because there's no default value for height. Okay, so this means if I have a task that I want to solve that is often achieved successfully by using the same values, then I may want to, in my creation of the function, specify defaults. Okay, so here I'm adding a little comment just to say that I'm actually changing things around. Give myself a little space for clarity. Okay, so now it's the same. This right here is just the code above, right? This is the same function, but I'm going to now specify values for the arguments, and these take the roles of default value. You can still change them, but now the function actually will run with these default values when we just call the function without argument specified. So let's return it. You can actually see that in the global environment, the function, it changed. We gave the thing the same name, right? So this is that, you want to be careful as you are updating things and as you're evaluating objects when you're assigning multiple things the same name. Here we're introducing increasing complexity as we go, so we're fine. But we did just overwrite this function, or this name, which pointed to this function with this function here. Okay, so what did we gain by doing that? Well, we have a function that you can call directly without having to specify the arguments. Okay, and if you know what the defaults are, you can change either of the arguments. Let me just. Okay. So this is going to have default value height equals 1. And this is going to have default value length equals 1. Okay, it works. Let's just to make sure. Length equals 1. Perimeter of rectangle. Yeah. Okay, that's right. Okay, good. All right. Nice. All right, so I don't like introducing this, but R will fill in if you know the value, if you know the order of the arguments and you know the values that you want, R will automatically fill it in. In my experience, this seems like it's faster because you're not filling in stuff, but the more complex the task, the more sort of involved you are in creating really complicated functions, the more tasks you work on, just the more opportunities there are to get confused. So I always will specify arguments. The exception being something where it's doing a function based on one data input or one vector input. Okay, so here would be a good, let's just continue with an example. Okay, I'm gonna just get that off the screen, it's bad. Okay, so let's create a new function where what we're gonna do is supply a numeric object x, and we'll just say that it's a length 1 vector, so just a scalar value. All right, so what we're gonna do is why did I do that? Okay. 2 equals x. So we're performing different exponents on, or we're evaluating different exponents on the inputted argument x. So as I'm typing this, a few things to note. So I have a value x in the global environment. This is an object given the name x. This x is an argument in a function. And a way to differentiate these two things is to think that basically this is global environment in R. This is everything that you've sort of worked on. What the function is going to do is it's going to create its own environment. Now this is complicated. Get into this later, talk about the scope environments of functions and whatnot. But basically, this is not the same thing as this object that's in the global environment. So if I create this function right here, then you can see it created a new function, and x is still preserved. And so, okay, a few things. So if I give it a value here, if I just call the function, it complains because argument x is missing with no defaults. R doesn't think, oh, there's this thing x, there's also this name in the global environment x, which references a value. These are just two different things. This is an argument for a function, and that it exists in its own little universe. And then there's our global environment for objects and functions that we have. Okay, two different things. Okay, so now, in this case, since we know we're having a function that's doing something simple to like a scalar object, I don't necessarily care about specifying the value, but I will probably still do it. Okay, so nothing happens. Okay, why? Well, what it's doing is it's, in this function, it's taking the argument x, we've supplied it a value 3 in each one of these cases. And then it is doing these tasks. It did do these tasks, but it did it within the environment of the function and not in R itself. So then as soon as the function ran, what was calculated in it is just gone. So it did the task and then it was gone. So we have to actually return something. Above, we see here in sort of an open task that isn't assigned anything, and so that it's the last line. Well, it's the first line, but it's also the last line, and then that's what just gets returned. So we did 4 things here. We probably want to display all of them. Okay. Again, this isn't going to do anything, right? Because I've taken this result thing, and now it's stored inside the function. So I have to iterate again. I could do this. Okay, now it works because now we have a last line that isn't being assigned to something, which then just lives in the function environment and gets instantly deleted as soon as the function is called. Okay, so, or if we want to be fancy and proper, we could do return. Oops, there we go. Okay, good. We're back. Okay. Alternatively, if we want to be quick and not fancy, we can just have the last line just be open. So remember, let's just combine things together. Okay, so within the environment of the function, we are creating 4 objects, which are functions, which are our input argument evaluated at different exponents. Then we are combining those together and returning it as output. All right, good. And we can, of course, try it at different values. Looks right. Okay. Okay. Also, R can easily combine functions together or use function composition. So you can see here that calc powers x equals 5. I'm just gonna returns a vector of 4 items, 4 objects, 4 numeric objects. If I wanted the average of those, I can just use mean. So essentially, this gets called. It returns a vector of 4 of length 4 objects, and then I can use a function on top of that and use function composition and get the average of those 4 values. Okay. So a concept that's going to be probably just beat down into your head as we go through this class is the concept of vectorization. You'll often hear vectorized code or vectorization, and basically R is built to sort of optimally perform tasks on vectors, and there's going to be more advanced functions that we'll use that will really demonstrate this point. But I think that there's like often a tendency to think in for loops for programmers or programmers coming from other places or programmers at the start when loops are introduced. But R kind of doesn't really play nice with for loops, and what I mean by that is that for loops are inefficient in R and they're slow. And so that it's better to think of vector objects in vector form and apply functions to them that can do specific tasks. Okay, so let's be a little bit more specific. Okay, so let's say I have a vector with some elements. Okay, just kind of hodgepodge of different numbers. Okay, let's provide spaces just to be somewhat organized. Okay, great. So now, demonstrating a new point, I'm using X as kind of just a dummy name in the lecture, something that I don't really care about. I'm not being descriptive with it. So you can see right now in the global environment, I have the object 42 assigned the name X. I'm about to overwrite it with this vector. Okay, so one thing, let's say you wanted to sum up all of the elements in this vector. People are often tempted to write this in a for loop, which we will cover for loops in this class, but we can see that this code will indeed, loop through all the elements and add them together. Oops. Okay. But it's just easier once we get understanding with R and the power that it has and the functions that exist to just use built-in functions in R or create our own to do these tasks. Okay, so there's a built-in function called sum, which would just sum the elements in the vector, the numeric elements in the vector, numeric vector, and return that sum. Okay, so if you wanted to, add the numbers of X together, or sorry, no, that would be something. If you wanted to take every separate element of X and add 1 to it, again, people sometimes default is to think in terms of for loops, but we can use arithmetic on vectors directly. Okay, so I have my element X again. It's the same thing it was before. And now you can see here that I'm going to take my object X, which is this vector of numbers, and I'm going to add 1. Okay, so it's a scalar value 1. What happens? I'm not going to assign anything yet, just to demonstrate. So you can see that when I do this task, the first element is 1 more in this after performing the task. Second element, also 1 more. So it's taking the 1 and adding it to each one of the elements. And of course, I can store that with a different name. Okay, so I think I just overwrote something in my global environment. But you can see that Now, if I'm taking vectors that have more than one element specified, then if I do these sorts of operations on them, the vectors will have to be the same length. But since they are, in this case, I can take y minus x and see that I did indeed add 1 to each of the elements. If I were to have some vector, okay, so this is, that's fine, I kind of left it. So now this vector is of length 3, contains numeric values. I'm going to give it the name z. You will see the global environment change. Now it's going to complain when I do something like this. See, it says that longer object length is not a multiple of shorter object length. So adding, subtracting, performing operations with two vectors is sometimes a little bit hairy. But if you're working with quantities of the same length, it isn't. Okay. All right. So we've already seen, I think we already covered length, but we have a lot of built-in functions that we can use on numeric vectors. This one is the multiplicative product of all the elements. Okay, great. Some other fun ones. Find the minimum element in the vector. Find the maximum element. These all come in handy for various tasks. Mean, variance, okay. Statistical functions, variance, standard deviation. Just to be sure, let's try this. Aha. If we recall, the standard deviation is the square root of the variance, and we use function composition to demonstrate that exact same point. Okay. Oh, yeah, let's do mean of x, and we can show that we can take the sum of x divided by the length of x to get the same thing. Okay, cool. And then there's all sorts of other functions that we can use. You can see some of the book for more details. Okay. And if we want to perform element-wise operations, we could just look at, so now remember, x is a vector of elements. So square root of x here is going to square root each one of the elements separately. Just like log will do the same task. All right, so that's a nice little introduction into objects and functions. And demonstrating some of the built-in things that exist with R, thinking about, okay, so, we started with basic objects, then we talked about assignments, and then moved to vectors, and then now we're kind of going into developing functions, and then talking about more restricting attention to numeric vectors and showing a brief display of functions that exist to do numerical and statistical tasks on vectors with numeric objects. Okay. Thank you for paying attention, and I will see you next time. All right. Bye.